All right. So for today's session, our main focus was meant to be this. PV is short for present value. It's a relatively straightforward concept. So the idea is you're trying to get the current value of some future stream of income. The idea is there's something called the time value of money. Okay, the time value of money means like a shilling today, if you invest it, might be worth more in the future. Okay, if you invest it. If you don't invest it, it might be worth less in the future. So the value of money changes with time. So that is what we're calling the time value of money. So we're saying the present value is the current value of an expected future stream of cash flow. It is based on the concept of the time value of money. So the present value is based on the concept that a particular sum of money today is likely to be worth more than the same sum in future because it can be invested and earn a return in the meantime. So the context here is the money is being invested somewhere and it is earning some interest. It is not just sitting somewhere. And of course, if it just sits somewhere, it will lose value, due to different factors, inflation and so forth. Then this present value calculation requires an estimate of a potential rate of return, which is called the discount rate. This is the rate, the approximate rate at which it will increase in value. Okay, so sometimes, because we are talking about the future, sometimes this can be estimated. Yeah, it needs to be estimated if it is not when you have not been given a fixed rate. Okay, so you can also calculate what is called the future value. Okay, I think I'm mixing those concepts. With present value, you have some cash in the future. You're investing some money somewhere. You want to get, let's say, $200,000 in future. What is the current value of that 200,000? Okay, so it's a bit of the opposite of what I'd said before. Apologies for that. It is you're looking at a future sum. You're trying to think what is the current value of that money. If it will be 200,000 in 10 years from now, what value is it now, given some discount rate, given some percentage rate at which it increased in value? Okay, while future value, which is what I have here, the future value is you have some sum today, how much will it be in the future? So the future value is relatively straightforward to understand because it's more like what you do when you invest some money and you are getting some, say, for example, some interest every year, whether it is compound or simple interest. Of course, the future value will be greater than the present value. Okay. So if you think about the two concepts, they are opposites of each other. Future value, you are here now, you have some money. Let's say you have 1,000,000 shillings. What will it be 10 years from now at, say, 8% per annum? What will it be? So the future value function allows you to calculate what the value will be in future. The present value function, you take some future sum of money and then try to work out what is its value today, or what must I invest today to arrive at that goal in the future. Let's say I want 3 million in my account at 10 years from now. How much do I need to put in today? Let's say at 6% interest rate. How much do I need to put today to reach that goal? That is present value. Okay, let's jump into an example. So how do we work out future value? We will use, there's an FV function, future value function, but there's a manual way of working it out. If you remember, I don't know if you have done the compound interest formula. You can use a manual way of doing it, but because we are trying to use Excel, we can use the FV function, this one that I've already used here. Let me zoom in a bit so that you can see it. So I have 100,000. I'm investing it for 20 years at the rate of 6% per annum. This is the annual interest rate. Okay, so what will the value of that money be? What I've done here is I've gone 1 year, 2 years, and 3 years, and so forth until 20 years from now. So we want to see how does it change every year. Okay. So for the first year, how do we use these numbers in the FV function? So let me just retype it here so that we can see it. So I have equals FV. Okay. And what are the parameters? If you're doing this in Excel, the nice thing with Excel is it will show you the parameters here. So that in the program I'm using today, Google Sheets, it's not showing me the parameters. But if you look at this, E18 is the interest rate. So the thing that will come first is the rate. Okay, E18. Then if you look at G15, it is the amount that you're investing, right? Then this one is it would be the PMT. Remember we talked about PMT earlier on, like what would be the monthly or annual amount that you invest. But in this case, because we are not investing every year, we are only doing one lump sum amount to start with, then that is what we will be waiting for the next 20 years. So we'll assign that value as 0. Okay, if you have access to a computer somewhere with Excel, please look at this, confirm that that is PMT. Then the last one is the amount that you are investing. So this would be, if you look at Excel, this would be called PV, present value. This is the amount that you're investing now. And you would normally use a negative, like you would make it minus something because it is money going out. Okay, otherwise, if you don't put that minus, you will get a negative answer. Okay, but ideally, because it is money that you are investing, it is, from your perspective, it is money that is going out. That is why we put a negative there, and it gives you a positive answer. So if I invest 100,000 today at 6%, in 1 year, it would be worth 106. In 2 years, it would be worth 112, and so forth. So the idea here is, if you're using Excel, the nice thing when you're using functions is there will be this wizard here guiding you. So you will just need to follow those steps and you will have your answer very quickly. That's why I said these functions are pretty straightforward. So that's future value. You're given some money today. What will it be worth a few years from now? So the question here I was answering was this one. What is the future value of 100,000 shillings 20 years from now, given an annual interest rate of 6%? Okay, that is a straightforward formula. Then let's try and talk about present value. What is the present value of 200,000 10 years from now? Like 200,000, this is the value of the money 10 years from now. So like we are now in what, 2024, 2034. If I have 200,000 in 2034, what is it worth today in today's money? That is what this question is talking about. Okay. Or 3 million 10 years from now, what is it worth in today's money? So the formula is very similar. So again, we have the amount that we need to work with. The years I'm working with is 10, and the rate is 8%. Okay, so this time round, I've kind of moved backwards. I've started with this is the value of the money in future. What is that worth today? If you use the calculation, the PV function, okay, notice again, we start with the rate, right? I'd like, again, like I've said, look this up in Excel. You start with the rate, then go to, so this should be the rate. Then G22 is where the present value should be. No, sorry, G22 is this. It is the period, the payment, that will be the NPER, the payment period. So remember, like when we were calculating IPMT, okay, there is a payment period. If we were talking about 12 months, each of those months was the payment period, okay? So this is the 10th year. It is what goes here, like which year are you referring to? The G22. Then there will be a zero value here because this will be FV. If you look at the formula in Excel, you will see that this will be FV, then this is the future value. This will be the value we are looking at. Actually, the FV is this one, the one here. Okay. So I would like for you to look it up in Excel. This one I assigned a 0, then I did this as this is a future value. Then again, because I want a positive answer, I'll make this a negative. Then if I press enter, what this 92,000 means is if I invest 92,000 today at 8% per annum, 10 years from now, it will be worth 200,000. Okay. 5 years from now, so I kind of worked it backwards. 5 years from now. So what is changing if you look at this formula compared to that one? I am changing the period. This one remains fixed, the interest rate, but the period is now 5 years. As I go along, you will notice it will keep changing to 4 years and so forth. So if I want to, if I want 200,000 1 year from now, this is what this 1 year means. If I want 200,000 1 year from now, how much do I need to invest at 8%? So I would need 185,000. So it's very close to the goal because the period here is shorter. I would need to invest a larger amount of money for me to reach that goal of 200,000. Right. So that is present value and future value. I will send you this worksheet as well so that you can read through the notes. Okay. And I think what I will do is also this worksheet, I did it in Excel. So what I've noticed is it works the same way in Google Sheets, except that the Excel is a bit more helpful. It will give you the wizard, the hints on what you're supposed to enter in terms of this function, these parameters here. It tells you what they are. It gives you the summary of the function. So that is PV. Let's move on to NPV. It is the net present value. Again, it's even easier to understand than the PV. Okay, it's a much easier calculation. But it is a summary. Let's read what it is. It is the net present value is a difference between the present value of cash inflows and the present value of cash outflows over a period of time. So in other words, you see like this net present, if you are investing some amount of money, I think there's an example we'll do here. So net present value, let's say for year one, and let's say you're investing this money for 10 years, like we have put here. The net present value, you see this present value changes. Every year there is a different present value. Okay, so the present value in 1 year, it is 185. So if you're thinking of this as an investment, it is a business. So the context here is a bit different. Here you are investing some money. Here it is the returns that money is giving you. So if you look at my example here, But before I jump into the example, let's quickly look at what the theory says here. I think I've talked about future cash flows. These are the expected amounts of money that will come from the investment over time. I think we have done that. Discount rate, it is the rate used to convert future cash flows into their present value. So that is that rate, that the 8% we have looked at. Then present value, we have said it is the current worth of some future cash flow, okay, calculated by applying the discount rate. So I think we have done these ones. So let's go into an example of the net present value and see how that will work. The first example I have here is you have an example, an investment with the following cash flows. Missed an H there, an S. Okay, so in year 0, this is when you invested. This is the amount you put in. It's like the capital you started with. Then every year you expect some amounts to make some amounts of money. And this amount that you put here when you're working out the net present value is the net, like the name suggests. Okay. There is it is the difference between the outflows and the inflows, or income and expenses. So what you get as the net cash or the net income is what you will use here. So when we say cash flow, it is the net amount. Okay. And like I've said, this formula is pretty straightforward. The more important thing is to be able to interpret it correctly. What does this amount, what does this figure mean when you get it? Okay. So how do we use the net present value formula? Again, we'll start with equals to, then NPV. Then when you open the brackets, if you are doing this in Excel, you will notice that it will give you the parameters. It will tell you what arguments you need to put into the brackets for you to get the answer. But in short, you will start with the rate, just like we start on most of the other functions we have dealt with. So the rate for this one is 14%. Okay, 14%, then comma, and then you highlight all the amounts, starting with the capital, the amount you started with. So you start with the 30,000 all the way up to the 5th year, the cash flows for all the 5 years. Okay, so pretty straightforward compared to the other ones. So we will, actually it is the cash flows you will select. So that is 15,000 up to 20,000. So D26 to H26, then you will add the capital amount, the amount you started with. Okay, so that formula again is, let me type it to avoid confusion, is equal to NPV. Then you start with the rate. You'll be given the rate in the question. Then comma, all the cash flows. You might be presented with a scenario where you need to calculate the net first. Then you will add the starting amount, and that should give you the net present value. Okay. You could, there are scenarios where you will also be asked to calculate the present values first. That means you will need to use the present value formula first. Then you will sum those present values. It should give you this same answer. Right, so that's example 1. Let's try example 2. This one is a bit more detailed. So we have the cash inflow, cash outflow. You first start by working out what the net is. So it's a difference between those two amounts. Amount 1 minus amount 2. Excuse me for a minute. All right, sorry about that. So I was saying, we have the net cash, which is 2,500. It is what I've put here. Okay, so these are the figures we are working with. The discount rate is 10%, and the initial investment is 3,000. So I'm assuming this is dollars we are working with. This one, give it a dollar sign. So if your cash, net cash is this, so I will put those in year one, it was 2,500. In year two, it was also 2,500. It might not be, this is more like an ideal situation. There might be some years when it will be less, or some years when it will be more. So one of the shortcomings of these functions is that there are certain things that you have to estimate, because these cash flows, we are hoping that it will be that in the future, but we don't know the exact amount. Okay, so it's more based on some estimates. Okay, even this rate of return is a bit of an estimate. So it is if you are asked what are the shortcomings of these functions, is one of the biggest shortcomings is that you have to work with estimates. Okay, so let's work out the NPV for this. These are the cash flows. Like we said, the formula starts with the rate, which we're given 10%, then highlight all the cash flows only, then add the investment, the initial investment. It's as simple as that. Start with the rate, highlight all the cash flows for the 5 years in this case, close the bracket, add the initial investment, and you have your final answer. Okay, so that's the NPV. I had done a manual calculation here, which I don't want to confuse you with, because what you're supposed to be learning is the function. All right, so one last one, it's called the internal rate of return, the IRR. Okay, so reading this definition, the internal rate of return is a metric used in financial analysis to estimate the profitability of some potential investments. Okay, so in this case, we're talking about the net present value. So it's a bigger figure. In this case, we are looking at a percentage. We are comparing what is the estimated percentage rate of return. Okay, you will compare it then with, when you work this out, you'll compare it with an internal estimate, a different estimate that you will have made. Let's just look at this definition that makes the net present value of all cash flows equal to 0. So the aim of the IRR formula is to make the net present value of cash flows equal to 0. Okay. And so how do we interpret this? Number one, yeah, if the IRR is higher than the required rate of return, the project is likely to be worth pursuing. So it is, since it is expected to generate returns above the cost. Okay. Then if the IRR is lower than the required rate of return, it indicates the project may not be viable. So these interpretations are important. So positive or negative IRR, a positive IRR, internal rate of return, indicates that the investment should generate a return and could potentially add value. So you should go ahead and do the investment. A negative IRR, on the other hand, implies that this investment is expected to lose value, okay, or possibly not cover its cost. So it may not be a profitable venture. So these formulas are used for judging whether an investment is worth doing or not. All right, so limitations. Let's talk about these limitations for a bit. It is IRR assumes that cash flows can be reinvested at the same rate, which is not always realistic. So there's some estimates, there's some assumptions made that the rate will remain the same for these 5 years, for example, right? So, and they're saying another limitation is that projects with non-conventional cash flows can have multiple IRRs, which complicates interpretation. So you might have different cash flows from different angles with depending on the context. You might have them coming from different countries, different businesses, and so forth, right? So it is a useful tool for evaluating investment opportunities, but it should be used alongside other things like the NPV. Okay, but how do we work it out? Again, pretty straightforward formula. So it's actually even easier than the NPV. If you look at this, we will just use we will just literally type equals IRR. That the Excel will pick it as the function. Then what will go inside, the parameters that will go inside will be the values, including the initial investment. So in this case, we are highlighting everything. So if you look at what goes here, it is C28 all the way up to H28. So C28 to H28. Okay, and it returns some percentage. Okay. So you will compare this with what is called the cost of capital, or the discount rate that you have been given in a question. The question will have given you a discount rate, but the result of applying the IRR to these numbers will also result in a percentage. You will compare this percentage with the percentage that you'll have been given, the discount rate that you'll have been given. Then if this is higher than the discount rate, then that is an investment worth pursuing. If not, then this applies. If the IRR is lower than the required rate of return, it indicates that the project may not be viable. All right. So that's an interpretation of the IRR. Okay. So what I'd gone ahead and done here is a bit of a summary. Okay, similar thing. So present value here, I used a bit of a manual formula. Okay, or I can use the PV. If you look at these numbers, they are the same. The manual formula is a bit more complicated, so I will not go into that, but let's look at this. So this is the normal PV calculation. So I invest that. These are the cash flows, expected cash flows, and these are the present values. So remember this 1,000, we're estimating to be 1,000 in future. What is the present value using the present value function of this 1,000? What is the present value of this other 1,000? So 2 years from now, if I'm getting a 1,000, what is that 1,000 worth today? If 2 years from now I'm getting, rather this is 3 years from now, I'll be getting 2,000. What is that worth today? That is what that number means. Okay, so the net present value will be a sum of these numbers. So if I'm working out NPV, I could do this sum, highlight all of this, and I get an answer. I can get that directly by using the NPV function. So NPV, start with the rate like we said, then highlight all this, then add the initial investment. You should get the same answer. That's why we are saying the net present value is a sum of all present values for that whole period. Okay, so for the 5-year period, we have worked out the present values would be this, if you remember what the definition of present value is, and that number should be the same as that number. Okay, I have not removed this should be plus this. I did not add this. I should add the initial investment there to get the same answer, right? Okay, so that's that NPV. I think actually the calculation, I'd done it here. So that's the same number as that one. IRR, like we have said, you will just write IRR, the function, then highlight all the values, including the invested amount. That's the difference. With NPV, you're only highlighting the expected cash flows and adding the invested amount outside of the brackets. I hope that makes sense. But with IRR, you're putting everything inside the same basket, and it is generating some percentage amount. And this percentage you will compare with this rate. This is the rate I was saying you would have been given a rate. So if this is higher than that rate, then that's a good thing. If it is lower than that rate, then there's a problem with that investment. And we can try and play around with these numbers and see if we can get a lower rate. Okay, 6% still marginally okay. If I have 1,000 here, then this becomes lower than that, which is a problem. Okay, so it gives you an IRR less than the ideal rate of return, then you have a problem. That venture is not worth getting into, right? So what I will do is send you a copy of this. Hopefully you'll be able to open it in Excel. And hopefully today we have been hearing each other. So I will send you a copy of this, and you should be able to get a recording of this. Then in the next session, which hopefully, if things go as they should, it should potentially be on Saturday, but if there's any change, I will let you know in good time. We will go through some more examples of the same thing, okay? And also mop up any other. We will look at the syllabus again and see if there's any functions that are left. And like I've also said, if you also do some investigation and find some other functions that we might not have looked at, you need to raise that and we will look at them. Otherwise, we started off by looking at this PMT and we did IPMT, and I think you have copies of this worksheet. And today we have talked about PV, NPV, and IRR, as well as doing some summaries of things we have done before.